This is the fourth videotape on elementary algebra review, the fourth review tape in elementary algebra. On this tape, we're going to be working out problems involving simple inequalities, graphing straight lines, and solving two equations and two unknowns, two linear equations and two unknowns. Okay, now most of you are familiar with the methods that we use to solve equations. We're allowed to add the same quantity to both sides of the equation, subtract the same quantity from both sides of the equation. We get an equivalent equation. We're also allowed to multiply or divide both sides of an equation by the same non-zero quantity, and we get an equivalent equation. When it comes to working with inequalities, we are allowed to add or subtract the same quantity both sides of the inequality, and that we get an equivalent inequality. That's okay. When it comes to multiplication and division, if we multiply or divide by a positive quantity, we maintain the same direction of the inequality. If, however, we multiply or divide both sides of the inequality by a negative quantity, then we must reverse the direction of the inequality. Let's try some examples. First example, we would like to solve for x and also sketch the solution set. And the inequality is 7 minus 4 times x plus 3 in parentheses is less than 3. Okay, now all this is a problem in inequalities. Don't forget what you already know about order of operations. By that I mean you do not say 7 minus 4 and simplify this to 3 times x plus 3. You realize that this multiplication, okay, of 4 times x plus 3 must occur before the subtraction. Okay, so let's do that. We can either multiply through by 4 and then subtract, or we can think of this as a minus 4 to be multiplied through, and then we add. So let's do that. Minus 4 times x is minus 4x, minus 4 times 3 minus 12, less than 3. What we're doing is simplifying on both sides, and then we're going to work on the inequality. Let's combine like terms on the left. We have a plus 7 and a minus 12, giving us a minus 5. So minus 4x minus 5 is less than 3. Now, we'd like to add 5 to both sides of the inequality, giving us minus 4x is less than 8. Now we would like to divide through by minus 4, but we remember that dividing by a negative quantity means we must reverse the direction of our inequality. So minus 4x and 8. We can divide through by minus 4, and we must if we would like to isolate x. But we must change the direction of the inequality from less than to greater than, so that we get minus 4x over minus 4. That is, x is greater than plus 8 over minus 4. X is greater than minus 2. Okay, and we can sketch our solution set. We can put a little number line in here. This is, say, 0. This is 1, 2, minus 1, minus 2. We want to indicate all x values that are greater than minus 2. We do that by means of an open circle here to indicate that minus 2 is not included, and then we move off to the right. All numbers greater than minus 2. If it was greater than or equal to minus 2, then we would fill in that circle there to indicate that minus 2 was a member of the set. This just indicates all values greater than minus 2. Okay, for our second example, solve for x and see what we get. Let's see, 3x minus 2 times, in parentheses, 5 minus x is greater than or equal to 12 minus, in parentheses, 2 minus x. Okay, don't confuse this with, say, 3x minus 2 in parentheses times 5 minus x. We're not multiplying here two binomials. What we're going to do is have 3x, and now we will distribute the minus 2 through the parentheses. Minus 2 times plus 5, that's minus 10. Minus 2 times minus x plus 2x. Greater than or equal to 12. Now here, think of this as like a minus 1 to be distributed. Minus 1 times 2 for minus 2. minus 1 times minus x but plus x. Now let's combine like terms on both sides of the inequality. The 3x and the 2x gives us a 5x. So we have 5x minus 10 on the left side, greater than or equal to 12 minus 2. That gives us a 10 plus x. OK, we'd like to get the x terms on one side, just like when we solve an equation, and the constant terms on the other. Let's subtract x from both sides to move the x to the left side. 5x minus x, that's 4x minus 10, greater than or equal to 10. And we would like to add 10 to both sides of this inequality to get 4x is greater than or equal to 20. And now finally, to isolate the x, we'd like to divide both sides by 4. And since that is a positive number, we maintain the same direction. In this case, I guess we can just do the division directly. Since we know we are going to maintain the same direction, we are dividing by a positive. You can do it on the same thing. However, just go back here and look that when we divided by a negative, I rewrote it because I had to change the direction of the inequality. When you divide by a positive, you maintain the same direction. And this gives me x greater than or equal to 5. And if we were going to sketch this on number line, say this is 0, 1, 2, 3, 4, 5. Since it's greater than or equal to 5, we would have a filled-in circle and then move off to the right. All x values 5 or greater. OK. Once again, I want to solve for x and sketch the graph. Minus 1 less than 2 minus 3x less than or equal to 8. When solving an inequality, a continued inequality of this nature, what we try to do is get x alone in the middle with numbers on the outside. OK, if that's our goal, we could do in this case, start by subtracting minus 2 from all parts of the inequality. Minus 1, minus 2, that gives us minus 3, less than. Here we're left with just a minus 3x, the 2's cancel, less than or equal 8 minus 2, that gives us 6. Now we would like to get x alone in the middle, and of course we have here minus 3x. We'd have to divide by minus 3, but in order to divide by minus 3, we have to change the directions of the inequality. So we can divide by minus 3, but the less than has to become a greater than. We can divide by minus 3 here, but the less than or equal becomes a greater than or equal. Divide by minus 3. That gives us minus 3 over minus 3, 1, greater than or equal to, here the minus 3's cancel, greater than. It was just a greater than here, a greater than or equal over there. 1 greater than x, greater than or equal to minus 2. OK, now I want to sketch this, and I find it easier to think about this in the reverse order. Instead of saying like A is bigger than B is bigger than C, I prefer to think of it C is less than B is less than A. In other words, to reverse it in the following form, minus 2 less than or equal to x less than 1. OK? This is equivalent to this one, and makes it a little easier to see it as far as, sketching it. This is 0, minus 2, and 1. All x values that are greater than or equal to minus 2 and less than 1. In other words, everything between minus 2 and 1, including minus 2, up to, but not including 1. So we have the following. The numbers that are greater than or equal to minus 2 and less than 1 at the same time. Between minus 2 and 1, including minus 2, but excluding 1. From inequalities, I'd like to move along to the idea of graphing straight lines. In problem number 4, we're going to sketch the graph of various lines. Sketch the graph in each case and label the intercepts. The first one, 5x minus 3y equals 15. We recognize this as the equation of a straight line. And the easiest way, we know we need 2 points to graph a straight line, and the first points that we would certainly try would be the intercepts. To find the x-intercept, we set y equal to 0 and solve for x. We're setting y equal to 0, we get 5x equals 15, x equals 3. X equals 3 is the x-intercept. And to find the y-intercept, we set x equal to 0. Setting x equal to 0 in the original equation, we get minus 3y equals 15. Dividing by minus 3 both sides, we get y equals minus 5. So here we have the y-intercept. Now, what does it mean by saying the x-intercept is 3? The line crosses the x-axis at the point where x equals 3. But if the point is on the x-axis, it has a y-coordinate as well. The y-coordinate would be 0 if it's on the x-axis. So it goes through the point. If the x-coordinate is 3, if the x-intercept is 3, it must be going through the point 3, 0. Similarly, if the y-intercept is minus 5, it crosses the y-axis at the point where y equals minus 5. But if the point is on the y-axis, its x-coordinate must be 0. So it must mean it goes through the point 0, minus 5. So the line is going to go through the point 3, 0, and 0, minus 5. And here we have the sketch of the graph of this line. X-intercept is plus 3. The y-intercept crosses the y-axis at minus 5. As a second example, I'd like to sketch the graph of the following line. Y equals 2x. Now, when we try to find the x-intercept, the y-intercept, turns out at the same point here. To find the x-intercept, we set y equal to 0. When we set y equal to 0, we get, of course, 2x equals 0, x equals 0. And if we set x equal to 0, of course, we get y equals 0. So the x-intercept and the y-intercept are the same. They happen to be the origin. We still need 2 points in order to graph the straight line, so we can just arbitrarily pick any other point. For example, we can say let x equal 2. And if x equals 2, y would be equal to 2 times 2, y would be equal to 4. Or we could let x equal 3, and y would be 6. This way we can generate another point on the line. So let's see what we have. It's going to go through 0, 0, and another point, say 2, 4. Alternately, as I said, we could let x equal 1, and y would be equal to 2. That would be another point on here. X equals 3, y equals 6, and so on. So we just need 2 points. We have the origin as 1, and then just to pick any other. OK, let's continue with sketching the graphs of straight lines. Y equals 4. And also, the next one, part D, x equals minus 2. I consider these slightly special cases because in the first one, of course, we have no x term, and in the second, we have no y term. OK, the graph of an equation, this form, y equals some constant. We know that this is well, it's a line. It's a horizontal line. Let's see why. To find points on this graph, they're all going to have y equals 4. The x value can be anything at all. So for example, we could have x equals 0, y equals 4, which would be here, 0, 4. We could have x equals 1, y equals 4, which would be over here. X equals 2, y equals 4. X equals 3, y equals 4. X equals minus 1, y equals 4. Okay, all points that have y equals 4, have the y coordinate equal to 4, they're located on a horizontal line 4 units above the x-axis. And in general, y equals any constant. This will be, its graph will be a horizontal line. Okay, y equals plus 4 is a horizontal line 4 units above the x-axis. If it had been y equals minus 1, it would be a horizontal line 1 unit below the x-axis. Similarly, x equals a constant indicates a vertical line. Now, where are the points that have x equal minus 2? Well, you could have, for example, x equals minus 2, y equals 1. X equals minus 2, y equals 2. X equals minus 2, y equals 0. X equals minus 2, y equals minus 1, and so on. In other words, the points are all on this vertical line, which is 2 units to the left of the y-axis. X equals minus 2, it's a vertical line, 2 units to the left of the y-axis. Now, for the remainder of this videotape, I'd like to give you some practice in solving systems of equations, 2 linear equations in 2 unknowns. In the videotapes in which we taught these lessons, we, of course, did them graphically as well, and we saw situations where you could have, for example, 2 straight lines intersecting like so, and we're looking for that point of intersection. But we know that to do it graphically is not very precise, and it's more convenient, actually, to do it algebraically. And we're going to be using the method of elimination in these examples. Let's get started. We want to solve, in each case, the system for x and y. And here's a typical example. X plus 3y equals 1. 3x minus y equals 13. Here we have a system of 2 equations and 2 unknowns, 2 linear equations and 2 unknowns. Now, the method of elimination. Okay, the idea is to somehow multiply one or both of the equations through by some constant so that when you add the equations, one of the variables will drop out, will be eliminated. Okay, let's see what we can do here. We notice the coefficient here is plus 3, and here it's minus 1. If we were to multiply through the second equation by 3, that will give us a minus 3y here, and when we add, the y's would drop out. Let's try this. So we're going to multiply through the second equation by 3. The first equation we'll leave alone. X plus 3y equals 1. The second equation, all the way through, we're going to multiply by 3. The left side has to be multiplied by 3, and the right side. On the left, of course, each term has to be multiplied by 3. 3x times 3, that gives us 9x. Minus 1y times 3 is minus 3y. 13 times 3, 39. And when we add the equations, we get x plus 9x, 10x. The y's drop out, which is what we wanted. 39 plus 1 is 40. Dividing through by 10, giving us x equals 4. Having determined that x equals 4, we can now substitute into either equation to determine what y is. So, for example, x plus 3y equals 1. We already know x equals 4. So 4 plus 3y equals 1. Subtracting 4 from both sides. 3y equals minus 3. And dividing through by 3, y equals minus 1. So we have y equals minus 1, x equals 4. Now let's check. We should check in the original equations, and we know it's going to work in 1, the first equation, because that's how we got it. But x plus 3y equals 1. 4 plus 3 times minus 1 should be equal to 1, and 4 minus 3 does equal 1. And checking also in the second equation, 3x minus y equals 13. 3 times x, 3 times 4, minus a minus 1 should be equal to 13. 12 minus a minus 1, that's 12, plus 1 should be equal to 13. And of course it checks out. So we have found the solution x equals 4, y equals minus 1 for this system of equations. Okay, in our next system of equations we have the following. X over 3 plus y equals minus 2. X minus 3y equals minus 6. Okay, now, before I get to the point of worrying about elimination, I am bothered by the existence of the fraction. I would like to first clear the fraction. Okay, so the first thing to do is to multiply both sides of that equation through by 3. The object here is to clear the fraction. X over 3 times 3 gives us x. Y times 3 is 3y. Minus 2 times 3 is minus 6. Second equation, x minus 3y equals minus 6. Now, it so happens that at this point, okay, we already see that if we add, the y's will drop out. But if that were not the case, we would now multiply one or both of the equations by the appropriate constant. The first thing, however, is to get rid of the fractions. Okay, so here we simply add the equations. 2x equals minus 12. The y's drop out. And we get, dividing by 2, x equals minus 6. We can then substitute into either equation. Let's take the second one. X minus 3y equals minus 6. If x is equal to minus 6 minus 3y equals minus 6. We add 6 to both sides, and we get minus 3y, adding 6 to both sides. Minus 3y equals 0. Dividing through by minus 3, we get y equals 0. Remember here, 0 divided by 3 is going to be equal to 0. Okay, here we divided both sides by minus 3. Let's put that in. Divided both sides by minus 3, and we got y equals 0. 0 divided by any non-zero quantity, of course, is going to give us 0. Okay, now let's just check this in both equations. We have our solution minus 6, 0. So here, minus 6 over 3, that's minus 2, plus 0 is equal to minus 2. And here, minus 6 minus 0 is equal to minus 6, and it checks out. And for the last example on this videotape, I'd like to do one more system of linear equations. Also involving two variables, two equations and two unknowns. 4x plus 3y equals 17. 3x plus 4y equals 18. Okay, this is slightly more complicated than the previous problem because we can't get away with just multiplying, say, one of the equations by, well, in this case, we're going to multiply both the top equation and the bottom equation through by numbers, and we're going to add in order to use this method of elimination. And what we're going to do is, say, multiply the top equation through by minus 3, and let's say multiply the bottom equation through by 4. That'll give us a minus 12x here and a plus 12x here. Eliminate the variable x. Okay, let's do that. 4x times the minus 3, that's minus 12x. 3y times the minus 3, that's minus 9y, equals 17 times the minus 3, minus 51. Second equation, multiplying it through each term by 4. 3x times 4, that's plus 12x. 4y times 4, that's plus 16y. 18 times 4, that's 72. Adding on the left side, the x's do drop out. Minus 9y plus 16y gives us 7y. Minus 51 plus 72 gives us plus 21. Dividing through by 7, y equals 3. Having found that y equals 3, we can substitute back into either equation. Let's try the first one. 4x plus 3y equals 17. We know that y equals 3. So 4x plus 3 times 3 equals 17. 4x plus 9 equals 17. 4x equals 8, subtracting 9 from both sides. And finally, dividing through by 4, x is equal to 2. And we'd like to check this in both equations. X equals 2, y equals 3. We believe that to be the solution, and it checks out very simply. 4 times 2, that's 8, plus 3 times 3, that's 9. 8 plus 9, that is 17. And over here, 3x, 3 times 2, that's 6. 4 times 3, that's 12. 6 plus 12 does give us 18. So that is the solution. X equals 2, y equals 3, and that brings us to the end of this videotape.